Okay, we're doing some review problems from page 310. So we're going to do one from each section in Chapter 5. Chapter 5 is all about the special properties of triangles. And it turns out that triangles, one of their special properties is they have three sides. Okay, I'm sort of kidding, but really they do. And each of those sides has a perpendicular bisector. So every triangle has three perpendicular bisectors. Every triangle has three angles, and each of those angles has a bisector, so every triangle has three angle bisectors. So three perpendicular bisectors, three angle bisectors. Perpendicular bisectors first. So this question asks if SQ, this line here, is the perpendicular bisector of RT, how do you know that RQ is congruent to TQ, and RS is congruent to TS? And they could have said RU is congruent to TU, and R, this red point over here, is congruent to T, this red point over here. Because perpendicular bisectors, that's what this is. This is a perpendicular sign, that's a B, that's an I. Sectors are equidistant from the two endpoints they bisect. All along the bisector, every point here will be equally far from A and B. So that's how you know. They gave us that. In the last problem, they gave us that it is a perpendicular bisector. Therefore, we know RQ is congruent to TQ because every point on here is equally distant from R and T. All right, the next question gives us more perpendicular bisectors, and it tells us, hey, where they intersect, the circumcenter is equidistant from the vertices of the triangle. Not to be confused with the angle bisectors, which that's going to be number 5. So number 4 is about the circumcenter. Not to be confused with the angle bisectors, which intersect at the incenter, which are equidistant from the side. So BW here is equal to AW. But here, it's not these things that are equal, it's the length of the vertices. KT is congruent to KR. So if we're supposed to find KR, really we want to find KT. I'm going to use GeoGebra for that. I basically copied the triangle here. A couple things I can add. So again, we're trying to find KR, which is the same as trying to find KT. And you see what I've done here is I mapped that they're giving us this 12 right here. And they're giving us this 32 right here. And since they're giving us 32 here, how do we know that this is 16? Well, what kind of segment is this? It's a bisector, a perpendicular bisector. It bisects a segment. And 16 is half of 32. So this is 16, this is 12. Besides being a bisector, what kind of bisector is it? A perpendicular bisector. So what kind of angle is this? A right angle. Perpendicular bisector, cut 32 in half, makes 16, and makes a right angle. And since this is 12, and this is 16, and this is a right angle, I've got myself a right triangle. A right triangle, right? This one right here. And so I can use the Pythagorean theorem, which says 12 squared plus 16 squared equals c squared. So I open my calculator. 12 squared plus 16 squared equals 400. Okay, good. So c squared equals 400. So then c is the square root of 400, which happens to be 20. Therefore, KT is 20, and since the circumcenter is equidistant from all the corners, KR is also 20. So my answer here, finding KR, is going to be 20. All right. Next problem, we would go to number 6. It says, name the special segments and point of concurrency of the triangle. All right. These seem to be, these little lines tell us that these angles are congruent to each other. Equal angles, equal angles, equal angles, equal angles, equal angles, equal angles. So what divides angles perfectly in half? The angle bisector. So number 6 is angle bisector. And the point of concurrency is where all the angle bisectors meet. Like I said, there's 3 of them. They are concurrent. That means they all intersect at one point. And there it is. And so that point is, so you got to know what it's called. It's in that section, section 5.2, and it is the in-center. All right, you've got to know your points of concurrency on this test, so good luck with that. Number 12, we'll go do 12 next. It's about mid-segments. Remember, there's two properties of mid-segments. They're parallel to one side, and they're half that one side they're parallel of. What is a mid-segment? It's from midpoint of this side to midpoint of that side. So look like we're doing some coordinate geometry. It tells us what the midpoints are. So find what the triangle is. So they're giving us 4, 3, 8, 3, and 6, 1. 4, 3, 8. So this triangle's mid-segments are 4, 3, so make a triangle. Whoa, I did not mean to zoom in. How did that happen? That's annoying. All right. 4, 3. Wow, this is... All right. 4, 3. 8, 3, and 6, 1. Okay, so 6 is less high.